Schedule 40 RNC conduit with the marking listed for direct burial is permitted for installation directly into the ground, negating the necessity for concrete encasement in many scenarios. The National Electrical Code, specifically Article 352, outlines the regulations for underground electrical installations. Crucially, Section 352.10 stipulates that raceways and cables placed directly in the earth must be listed for direct burial or must be housed within approved raceways, sleeves, or alternative approved methods. The direct burial listing indicates compliance with this requirement. Type EB Schedule 40 conduit represents a specialized conduit type engineered for direct burial applications. Its construction features a thicker wall relative to standard Schedule 40 conduit and incorporates a corrosion-resistant coating. The concrete encasement provision referenced within the National Electrical Code Handbook Article 352 is specifically applicable to electrical installations within hazardous classified locations or instances where the conduit is prone to significant physical harm. Consequently, in non-hazardous environments where the conduit is not susceptible to severe physical damage, Schedule 40 RNC conduit bearing the listed for direct burial designation can be directly installed in the ground without concrete encasement. To expand upon the points, it is important to understand the different types of conduits and their intended uses. Schedule 40 PVC conduit is a common type of electrical conduit used for various applications. Its schedule number indicates its wall thickness and resistance to pressure. Schedule 40 is a common choice, but other schedules like Schedule 80 exist, offering even greater physical protection. RNC stands for rigid non-metallic conduit, commonly made of PVC, which is resistant to corrosion. This makes it suitable for underground applications. Type EB conduit is a specific type of RNC that's designed for encasement in concrete. It may have a thinner wall than standard Schedule 40, and the NEC typically requires it to be encased in concrete for protection. The National Electrical Code, or NEC, is a set of standards for safe electrical installation. It's updated every 3 years, and local jurisdictions often adopt it into law. Compliance with the NEC is essential for ensuring the safety of electrical systems. Direct burial refers to installing electrical conduits or cables directly in the earth without any protective encasement, like concrete. Direct burial listed conduits are specifically manufactured and tested to withstand the stresses and conditions of being buried underground. These conduits are made of materials that resist corrosion, moisture, and physical damage from soil and rocks. When a conduit is marked listed for direct burial, it means it has been tested and certified by a recognized testing laboratory, such as UL or ETL, to meet the requirements for direct burial applications. This listing provides assurance that the conduit can withstand the environmental conditions it will encounter underground. Concrete encasement involves surrounding the conduit with concrete. This provides superior physical protection against damage from impacts, soil shifting, and other external forces. Concrete encasement is often required in areas where the conduit is likely to be subject to physical damage, such as under roadways or in industrial environments. Hazardous locations, as defined by the NEC, are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, liquids, or combustible dusts. In these locations, electrical installations must be designed to prevent ignition of the hazardous materials. Concrete encasement is often required in hazardous locations to provide additional protection to the wiring and prevent sparks or arcs from igniting the surrounding atmosphere. When selecting conduit for underground installations, several factors must be considered. Firstly, the type of soil is important. Corrosive soils can damage certain types of conduits, so it's essential to choose a conduit material that's resistant to corrosion in the specific soil conditions. Secondly, the depth of burial must be considered. The NEC specifies minimum burial depths for different types of conduits and cables. These depths are designed to protect the wiring from physical damage and ensure that it's not disturbed by digging or other activities. Thirdly, the potential for physical damage must be assessed. If the conduit is likely to be subject to impacts or other physical stresses, concrete encasement or other forms of protection may be necessary. To summarize, let's review the key points. Schedule 40 RNC conduit marked listed for direct burial is allowed to be installed directly in the ground without concrete encasement in many cases. The NEC allows direct burial of listed conduits, but it also requires concrete encasement in certain situations, such as hazardous locations or where the conduit is subject to severe physical damage. Type EB conduit typically requires concrete encasement, while direct burial listed conduit does not, provided it meets the requirements of the NEC. Understanding these requirements is crucial for ensuring safe and compliant electrical installations. To provide further clarity, it's useful to illustrate with a few practical scenarios. Firstly, consider a residential landscape lighting project. In this case, you're running low-voltage lighting cables underground to illuminate garden features. If you're using Schedule 40 RNC conduit marked listed for direct burial, you can typically bury it directly in the ground without concrete encasement, provided the burial depth meets NEC requirements and the area isn't subject to significant physical damage. Secondly, imagine a commercial building where you're installing underground power feeds to outdoor equipment. If the conduits are running under a parking lot or driveway, where they're likely to be subject to heavy traffic and potential impacts, concrete encasement would be advisable, even if the conduit is listed for direct burial. This provides an extra layer of protection to prevent damage to the wiring. Thirdly, consider a manufacturing plant with areas classified as hazardous locations due to the presence of flammable materials. In these areas, concrete encasement would be mandatory for all underground electrical installations, regardless of the conduit type, to minimize the risk of ignition. Furthermore, it's essential to be aware of local codes and regulations. While the NEC provides a baseline for safe electrical installations, local jurisdictions may have additional requirements or restrictions. Always check with your local building department or electrical inspector to ensure compliance with all applicable codes. When installing direct burial conduit, there are several best practices to follow. Firstly, always use conduit that is specifically listed for direct burial. This ensures that it meets the necessary standards for underground use. Secondly, carefully inspect the conduit for any signs of damage before installation. Cracks, dents, or other imperfections can compromise its ability to withstand underground conditions. Thirdly, ensure that the trench is free of sharp rocks or debris that could damage the conduit. It's often helpful to create a bedding layer of sand or fine gravel to protect the conduit. Fourthly, maintain the minimum burial depth specified by the NEC. This depth varies depending on the voltage of the wiring and the location of the installation. Fifthly, when backfilling the trench, use care to avoid damaging the conduit. Compact the soil in layers to provide uniform support. Sixthly, clearly mark the location of the buried conduit with warning tape or other appropriate markers. This helps prevent accidental damage during future digging or excavation. In summary, direct burial of Schedule 40 RNC conduit marked listed for direct burial is generally permitted, but there are important exceptions and considerations. Always refer to the NEC and local codes, assess the specific conditions of the installation, and follow best practices to ensure a safe and compliant electrical system. Understanding the nuances of direct burial installations and the requirements of the NEC is crucial for electrical professionals and anyone involved in electrical work. By following these guidelines, you can ensure that your underground electrical systems are safe, reliable, and compliant with all applicable regulations.